In a group of 4 employees, 2 are high risk, 2 are low risk. This year, each high risk has probability zero point 0.6 of no accidents, and each low risk has probability 0.9 of having no accidents. The occurrence of accidents are independent. Calculate probability that at most one employee has one or more accidents this year. So let H be the number of high risk persons having accidents, and L be the number of low risk persons having accidents. Then H is binomial, but N is 2 because there are a total of 2 people who are high risk. See, in a group of 4, 2 are high risk and 2 are low risk. So number of high risks are 2. So for H, N will be 2, and P is the probability of accidents. So we are given that it's 0.6 probability that the high risk will not have an accident. So the probability that a high risk will have an accident will be 1 minus 0.6 equals 0.4. Similarly, the low risk persons having accidents is also binomial with N2 because there are 2 total low risk people. And the probability that a low risk will have an accident will be 1 minus the probability that a low risk will not have an accident. So 1 minus 0.9 equals 0.1. And probability of zero accident would be that none of the 4 have accidents. So 0.6 and 0.6 that the high risk will not have accidents, and 0.9 and 0.9 that the low risk will not have accidents. And so when we multiply all these 4, see, because this is like saying that first high risk doesn't have an accident, and second high risk doesn't have an accident, and first low risk doesn't have accident, and second low risk doesn't have accident, and we know and means multiplication. So that's why we multiply all these 4. And so the probability of zero accidents would be 0.2916. And the probability of one accident. So the reason why we are calculating the zero accident and one accident is that the question was asking what's the probability we have at most one accidents, which means zero accidents or one accident. So we already have calculated zero accidents. So the one accident will happen if a high risk person has one accident and low risk person doesn't have an accident, or if a high risk person doesn't have an accident and a low risk person has accidents, and we know or means addition, so we have an addition here. And so this is pH is equal to 1 times PL is equal to 0 because and means multiplication. And similarly here, this would be the H equals 0 and L equals 1 will translate into H equals 0 times L equals 1. And so we apply the binomial for H equals 1. So that would be 2 combination 1 because in this case X will be 1 in the binomial formula. So NCX will become 2 combination 1. And P was 0.4 for the high risk. So 0.4 power 1, 0.4 power X, and 1 minus 0.4 power N minus X. And then L equals 0 means that we just have 0.9 times 0.9 because remember we're talking about uh, 2 high risk people and 2 low risk people. So among the 2 high risk people, we want one accident, which is this binomial formula part. And then among the 2 low risk people, if it's 0 accident, then it means both of them have no accident, so 0.9 times 0.9. That was the no accident probability of low risk. And similarly here, H is equal to 0 means both the high risk will not have accidents, so 0.6 times 0.6. Each of them has 0.6 probability of not having accident. times probability that one of the two low risk will have accidents. So we apply the binomial 2 combination 1, and low risk p is 0.1. So 0.1 power 1 and 1 minus 0.1 power n minus 1. And this all ends up being 0.4536. That's the probability of one accident. So the probability of at most one accident would be 0 accident plus 1 accident. So 0.2916 plus 0.4536. That is 0.7452. Choice E.